55, I want you to hang on to it. If you didn't get it finished, you're going to you finish it. I'm not sure what I'm going to do with it. My first block was sort of my guinea pigs a little bit to what we're trying to do today. We didn't get through as much as I'm hoping, so now you guys are going to be guinea pig number 2. Because I'm trying to use stuff on the computer and trying to see how I actually want to do this. And I apologize because I can't see how it's going to work unless I have students sitting here with me. Because I can't, your website and stuff that you look at for the book looks completely different from mine. So I'm on mine saying, okay, yeah, we'll do this. And then in first block, I have them pull it up, and theirs looks completely different than mine. I'm like, all right, something ain't right here. What's going on? But that's just the way it is, and it switches stuff up and everything. So we're going to try some things on the computer and stuff. Again, just set the computer off to the side. For now, what we want, page 55 in the book. Page 55, we're going to go over a few of these problems. We may skip a couple of them that I have written up here, because Cooper said he wanted to see these other ones, so we may just do those other ones instead. For a problem like 13, the first ones, are they very difficult? They're pretty easy, right? You're just finding the midpoint. The formula for midpoint, if you're on a number line, is just m equals, I think they got it the other way. Doesn't matter which way we put the x's. Makes no difference which way the x's go. So let's do 13, then we'll skip 15. On 13, segment DE. What's the coordinate of segment or of point D?
7.
Coordinate of point E?
11.
Ignore that. Somebody add those two for me. What's 7 plus 11? 18 divided by 2?
9.
So what's the midpoint for that segment? Just the coordinate 9. All right? Those are easy, right? Having no trouble with those? So we can skip 15. 19, how about 19? Anybody have trouble with those? Just using the formula, right? Except this formula looks more like this. See this one, 5, 11, and the other point was 3, 1, thank you. If I graph these two, first of all, if I graph these two, when I draw my graph, do I want to put everything right in the middle? What do I notice about these 2 points? All positive. So we probably just want the first quadrant. Right? Maybe do something like this. Here and maybe there, just to make sure we have enough room. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's one of our points. If I quit leaning on the board, my pen would write better. 3, 1, 1, 2, 3, 1. Our other point. When we take a test over this, supposed to be next class. I'm not sure about that. We may put it off. We'll see. We may put it off till Friday. We'll decide that at the end of class. When we have something like this, earlier this chapter, we found what for that segment? What did we use this formula for? To find the distance, find the length of that segment. So you're going to have to be careful on the test and know, hey, am I trying to find the distance here or am I trying to find the midpoint? And you're going to have to read the problem carefully and it'll tell you. This one we know because what's it say in the directions? Find the coordinates of the midpoint. Alright, so we're trying to find the coordinates of the midpoint. Again, the midpoint formula looks like this. I'm going to write it this time. X sub m, comma, y sub m. I forgot my parentheses. Equals x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. This is our x1, y1, x2, y2, and we're just going to plug them in. Silas can probably do this, most of it in his head, I'm guessing, right? Did you write it all down every single time? Maybe once, and then you said, this is easy, let's just get on. What's our x's this time? 5 plus 3 divided by 2. What's our y's? 11 and 1 divided by 2. Does it matter if we turn them around? What's 5 plus 3? 8 divided by 2. 11 plus 1 divided by 2. We're saying, do we do anything to that once we get to that point? That's our answer. Don't go any farther. If we're doing the distance formula, we should get one number as our answer. Doing the midpoint, we should get that. So we're saying the midpoint should be about 4, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Does that look like that's about the midpoint of that segment? Again, do you have to graph it every single time? Not necessarily. If it helps you, if it helps Dominic to look at it and see it, then graph it. On the test, I'll probably put a little graph on there, and if it helps you to graph it, you use that graph. If not, you leave it blank. Not the whole question, you leave the graph blank, right? Still do the question. I better make sure everybody understands that, because you told us we could leave it blank. That's what I'll hear. Not from you guys. My other classes, maybe. Does everybody understand both of those? Can we jump on to some of the others? Let's do 33. 33 is a little tougher. These are the ones that Jameson up here, he probably had a little trouble with. C is -5, 4. That's supposed to be a comma. And B is -2, 5. Give me a second, I'm going to graph these. Those are pretty normal numbers, so I can probably be right about in the middle. -5, 1, 2, 3, 4, 5, 2, 3, 4. Let's see. B is -2, 1, 2, 3, 4, 5. The bad thing here, somebody read the directions for us. What'd they say? So what's the midpoint? B is. So B is the midpoint. C is one of the endpoints, and A is one of the endpoints. Well, where's A at? They didn't tell us about that. We have to find it. Where would it be located? Like here? Where's it going to be at? Top right? Over in here somewhere? And well, all we're doing is we're following this segment straight out. Somewhere in there somewhere maybe? That looks sensible? So we're trying to find this endpoint. We're using the formula, but we're using it backwards. If we're given a formula, what's the formula to find the area of a rectangle? Everybody knows the formula to find the area of a rectangle. Here, I think I picked an easy one. Nobody ever knows it. Length times. Is that the formula for area of a rectangle? Not quite. This isn't a formula. All formulas have a what in it? We gotta have an equal sign. That's the formula, right? So with the midpoint formula, we use that one side all the time and don't really pay a whole lot of attention to the other side. And that it works out the same with most all formulas. We use this side all the time. We don't really pay a whole lot of attention to the other side. But with the midpoint formula for these kind of problems, we have to. What's that little M stand for? Midpoint. So this is the x coordinate of the midpoint and the y coordinate of the midpoint. Then the rest of the formula. Is it alright if I leave the subscripts off the rest of these? Is that going to bother anybody? Is that going to be alright? I get tired of writing them. Add the x's divided by 2, add the y's divided by 2. Now with this, all we're going to do is we're going to substitute into all these places whatever ones we can and solve for what we're missing. I go up here, they told us one of these, which one was the midpoint? B was, right? So this is our x sub m, that's our y sub m. This is one of our x's, that's one of our y's, and we don't know the other. What am I going to put in place of x sub m right here? -2, comma, -5, 5, just positive 5, right? Equals, I don't know this x, so I'm just going to leave it as x, plus, what's the other x? The x I do know. -5 over 2, comma. I don't know the first y, but I do know the second one. What's the y that I do know? Might be helpful if you have something like this written down there. I don't remember what examples we got through in the notes last time for this class. But if you're not sure about how to do these, this might be a good idea to jot some of this down there on your homework or somewhere so that you make sure you understand it. How am I going to solve this with all those commas and everything in it? Can you solve it like a normal equation? Got to split it up. This x, -2, has to equal what part on that other side? The x part. So it has to equal that. And I'm just going to rewrite this. X plus a -5 is the same as saying what? X minus 5, good. Is that something we can solve? Let's do the y before we do that one. Let's go ahead and set up the y. What's this y over here going to equal? What's it equal to on this other part? Y plus 4 over 2. Still, doesn't that make any sense? Is this stuff easy? You could have figured this out on your own. You didn't need Ebersole's help. Is that right? You're having a rough day? You just hate my class? Because I like you. Don't make me cry by making me debate. Are those things that we can solve? How do you solve this first, the x part? How do we get rid of this big fraction here? Multiply both sides by 2. Multiply that side by 2, multiply this side by 2. What's 2 times -2? What happens with the 2's over here? They just cancel out. That's the whole purpose. Right? They cancel each other out. What's left on that right-hand side? X minus 5. Ignore that straight line going up through there. Now what do I do? These cancel out. You're left with x equals, what's -4 plus 5? We're finished? Is that where you finish at? Probably not. Still have to find the what? Y. How do I do that? Divide both sides by 2 again. 2 times 5 is? These 2's cancel out. That's with y plus 4. Now what? What's y equal? So what's my answer? It's a point, right? And it's 1, comma, 6. That's the, is that the midpoint? That's the other endpoint that we were missing. Let's look out here and see. 1, 1, 2, 3, 4, 5, 6. So we're saying that point right there. That should be point A. Does that look like B would be the midpoint for A and C on our graph?
Yes.
Nothing real hard about this. You've just got a little extra work to do. The hardest thing is that most students don't like that big fraction, and you just got to know to get rid of that big fraction, you multiply both sides by whatever the denominator is. In this case, it's 2. Bored with those? Think you can handle that? Taryn, you think you can handle those? Handle that? Easy stuff? Now, Jameson over here, if he graphs it, and he just sort of figures it out some way, what that other endpoint is Ebersole going to be real mad at him? I don't care how you figure it out. I mean, I'd rather you do the math, because I think it's, if you do it a couple times, it's going to be easier that way. And more often than not, if you do the math, you're going to get the correct answer. Whereas if you just sort of guesstimate and try to figure it out, you might get the right answer, you might get something just close. Which ones did you say, Cooper?
I'm good now.
Figured it out, you sure? I know what happened. Cooper was trying to do those ones with the pictures, wasn't he? That's the ones you were having trouble with, the ones with the pictures? Oh, wasn't. Figured he was looking at number 55 there, and he seen the ice cream cone, and then that got him all sidetracked. He couldn't think about nothing else other than getting himself an ice cream cone. Probably right, aren't I, Logan? That's probably what happened to Cooper. Squirrel! Nobody else got it, Dominic. I don't think they understood the squirrel thing. You understand it, Cooper?
Yeah.
Because I use it quite often throughout the year, so. James, you understand the squirrel thing? You ever seen that movie? Probably not. So mommy doesn't sit and watch little cute cartoon movies like that with you?
That's not a good person.
They make you cry? Is that why James didn't watch it? James, would you cry? Didn't want nobody to see you crying and seeing him watch it. Other questions on that assignment? 54. On 54, a computer software designer is creating a new video game. Designer wants to create a secret passage that is halfway between the castle and the bridge. This looks like the game, you guys probably don't know, but Zelda, when I was growing up. That's exactly what it looked like. It was just on a grid like this and stuff. Where should the secret passage be? So halfway between the castle and the bridge. Somebody help me out. The castle. We'll call it C. What's the coordinates of the castle?
Castle. 12, 7.
Everybody agree with 12-7? What's the coordinates of the bridge?
5,
5-14?
14.
Everybody agree with that? Now we want to be halfway, so that's going to be the what? The midpoint. Do we have to do all that long stuff that we just did on that last problem? No, this time all we really have to do is take the x's, add them together and divide by 2. Take the y's, add them together and divide by 2. What are our x's this time? 12 plus 5, divide by 2. You might need your calculator out. I don't know. What's our y's? 7 plus 14 divided by 2. Somebody help me out. 12 plus 5 is what?
17.
Divided by 2.
8.5.
8.5. 8.5. 7 plus 14
21.
divided by 2.
10.5.
In your book right there, find that point. 8.5, 10.5. Does it look like it's halfway? Does it look like it's halfway between the castle and the bridge? Bell, what was your question? 39? Problem 39. First thing we got to do on 39 is be able to draw this picture. It says, suppose M is the midpoint of segment FG. What am I going to draw here? Segment FG. F here, G there. And then we got point M. Where's it at? Somewhere in the middle right there. Exactly in the middle, supposedly. What do we know about these two? Segment FM and segment MG. They're equal. What's the geometry term? Congruent to each other. They're congruent. They tell us segment FM is 5y plus 13. We labeled stuff like this earlier this year, right? Segment MG, so from here to here, is 5 minus 3y. And we want to know how long this segment is. What are we going to do with these two expressions that they gave us? On the stuff that we did earlier this year, we would have added them and set it equal to the whole thing. Is that going to work this time? We don't know the whole thing, do we? But what do we know about those two segments? They're equal. So what equation can I set up? 5y plus 13 should equal what? 5 minus 3y. Make sure. So if we're having trouble with this, then we need to go back over this. On some of the stuff that we did earlier this year, we took this segment plus this segment equaled the whole thing. All right? That's not going to work this time because do we know the whole thing? But what do we know about these two segments? They're congruent. They're the same. So now what we're going to do is say this has to equal that. Now again, when we get test time and Nick's doing a problem on the test, does that mean that that's the way we set it up every time? Sometimes they'll tell you the whole thing and you'll have to say this plus this equals the whole thing. You're going to have to be able to pick out which problem's which. What do I do to start to solve this? First step. Go ahead, Cooper. Add 3y. Mr. Harrison must have done something right with Cooper. What's 5y plus 3y? 8y plus 13 still equals, these cancel out. 5 on that side. Minus 13 on both sides. Those cancel, you're left with 8y equals negative 8. Now what?
Divide by 6, you get divide by 8.
What do you end up with? Negative 1. Is it alright for y to be a negative? Yeah, it's alright for y to be a negative. What can't happen? Can those links be negative? The links can't be negative, but the y can be negative. So what we need, I don't know, what did they ask us? I'm sorry, this looks like 18 there. It's supposed to just be a -1. What did they ask us to find on 39? Each missing measure. What's that mean? We want to find all the measures in total. How many different segments are there in this picture? Give me one of them. Segment what? FM. Can we find the length of segment FM? By doing what? So 5 times a -1 plus 13. What's 5 times -1? 5 times -1 is -5 plus 13. So how long is segment FM? 8. What other segments are in this picture? MG, good. What do we know about FM and MG? So if this one's 8, what's that one? Let's put it in there. There's one more segment in this picture. What is it? FG. Now I don't know if they wanted you to find this one or not, but we're going to. Now we can go back. If this segment's 8, that segment's 8, how can we find the whole thing? Add them together. What do you come up with? Tearing it up. Other questions? Will that help? Please remember, because when we take this test over this stuff, sometimes we want this segment plus this segment equals the whole thing. Other times we want to say this segment equals that segment, depending on the information that they give you. This first test, that's probably, I don't want to say it's not going to be a hard test, but it's going to be hard because we have so many things that are real similar to each other. If you do the wrong thing for the wrong problem, then you're out of luck. I would be more explicit than the book was. I would probably on the test, I would say find segment FM, or find segment FM and segment MG, or find the value of Y. I would try to make sure that I didn't leave it out, what I actually wanted, because they sort of made it a little vague.
For the test, are you gonna leave the formulas up there?
Probably, what I'll probably end up having to do is I'm gonna have to erase this here pretty soon. And usually like the distance formula last year, it stayed on my board from the 2nd or 3rd day of school all the way through the school year, which helps sometimes, and there's other students that it didn't help them at all. I'm like, are you kidding me? It's right there. That wouldn't be used that, would it? Do you know how to use your surroundings? Like when we go and we take test over polygons, and I see you doing this, looking, seeing where Ebersole is at. You gonna do stuff like that? That's good. Or when we go to talk about congruent triangles, and you have to look up here and it says SSS, and we'll see it split and see what that is, so that you can remember it on that test. That's good. Use your surroundings. By that time, I'll probably have more posters up. They're all sitting over there, all these different posters, and always kills me because we'll take something over. Where's it at? Here pretty soon, next chapter. It's got obtuse and acute, and we'll take a definitions test. And it tells right there. And then Jameson misses what an acute angle is on the test. And my head just like wants to explode because I'm thinking, Jameson, look at the freaking poster right in front of you, man. Next thing I want you to do, you're going to come up here, you're going to grab these two towels. You know I probably would have said something different if my boss wasn't here right now. Huh? On this, review notes. I don't know, when we do take the test, a couple different things may happen. I may say you can use no notes. That's what Jameson wants. I may say you can use all your notes. I may say you can use these review notes. All right? The one thing I know for sure that's going to happen, listen closely to this, because there'll be a couple of you in here that's going to be mad at me. If you do not have a binder, by the time we take this test, you do not have a binder, and these notes are in that binder, you're not using any of them. All right? So have a binder, have the notes in there, and I'm going to let you use the binder. I'm not going to let you just pull a bunch of papers out of your book bag and say, these are my notes. I'm not going through that headache. If it's in the binder like it's supposed to be, then you'll get to use it. Does everybody understand that? Because there's going to be somebody in here you know that's going to be mad at me, right? When I say, no, put it away. I told you, put it away. So have a binder set up, ready to go. I'm probably going to allow you to use your entire notes, but the good thing, Zach, with this, if you got to flip through your entire notes, it starts to get long and tedious. If you got everything written down on these couple of pages here, might make everything a little easier for you. First one, fill in stuff as we fill in all the way down through this. Number one, know the undefined terms. What were the three undefined terms that we talked about at the very start of the year? Line, now we set them all backwards. Does that matter? Points, lines, planes. How come those three terms are undefined? If I tell you to draw a line, can you do it? If I tell you to draw a plane, can you do it? If I tell you to draw a point, can you do it? Now, if I tell you to draw a segment, can you do that? Yeah, a segment starts somewhere, ends somewhere. So we can actually show that.
My laptop
Your laptop's being weird.
a bunch of calculators.
Might have to shut it down and start it back up or something. Give me an example of a point that we could use in the room here. Point C up there, that's the easy one, the one I drew on the wall. How about you? Could we use you as a point? Give me an example of a line in the room. Ceiling, this on the whiteboard. How about your pencil, your pen, maybe something like that? Give me an example of a plane in a room. Ceiling, the whiteboard, the wall, so on and so on. Make sure you know how to name those. We'll talk about them. Be able to use an axiomatic system. Remember, an axiomatic system is like a game or something. It's just something that has rules used to draw conclusions. Guaranteed there's going to be a few problems on there like those ones that we did. If you remember at the start of the year, the ones that we did with the crazy animals and stuff. There's going to be something like that. It's going to say something like Sally bought a 50-cent item at the store. Johnny bought a 25-cent item at the store. Kelly bought 2 items that totaled up to 80 cents. And then it's going to ask you questions about it. What can you conclude from all this? And you're going to have to use all those things that they told you, all those rules, to decide things. Know the 2 types of geometry. Anybody remember the 2 types of geometry that we talked about? Synthetic. Anybody remember the other one? Analytic. That's supposed to be an I. Analytic. How can we tell the difference? Anything that's on a graph is analytic. Everything else is synthetic. So that's the easiest way. Either it's analytic because it's on a graph, or it's got to be the other. Be able to name geometric figures. What are some of the figures that we talked about? Array, segment. What else? Comma. Line. What else? Plane. So on, so on, so on, right? All those things. Now, when you're naming those, you've got to remember the symbols and be able to use the symbols. Like, what's the symbol for array? How many letters to name array? 2 letters to name array. How many letters to name a segment? 2 also. How many letters to name a line? 2 also. So you got to know the difference. What's the symbol for a segment? Something like that. Symbol for a line, something like that. And the symbol goes above the 2 letters. How many letters to name a plane? Maybe 1. What else? Maybe 3. Depends, right? Remember, a plane might look something like this. If they give you a letter up here in the corner that doesn't correspond to a point, then you can name it with just that 1 letter and the word plane, so plane B. If they don't give you that, if they just give you points on the plane, you may have to use 3 points, and we'll talk about that here in a second. No definitions. These are just some of them. Collinear. Anybody remember what collinear means? On same line. Good. On same line. How about coplanar? On same plane. Things on the same plane. Ignore that extra part going up through there. Axiom and postulate. I thought we went over these pretty well, but my first class made it sound like they didn't have a clue. If I remember, what's an axiom or a postulate? We didn't cover it too well then, I guess. axiom or postulate is just a rule that is assumed true. So an axiom or a postulate is just something that we assume to be true. You know, that's hard to believe that you ever do that in math, because you probably had math teachers in the past that said, don't assume things. But if it's an axiom or a postulate, we assume that it's true. Anybody remember what a theorem is then? Alright, so this has to be proven true. Got to be proven true. Theorems have to be proven true. Axioms, postulates are assumed to be true. Number 6, 2 points make a what? Any 2 points in the world make a line. Figure it out, James. Quit. Next one, 3 blank points make a, let's do the last blank first. 3 points make a what? Plane. What kind of points do they have to be? Non-collinear. What's that mean? Not on the same line. It's got to be 3 points that are not on the same line. And that goes back to when we're naming it, it's got to be 3 points that aren't all on one line. We should just take the test today. This is easy stuff, right? Next one. Know how geometric figures intersect. 2 lines. If I have 2 lines, how they intersect? A point. Take 2 of your fingers, cross them. They intersect at exactly 1 point. How about 2 planes? How do they intersect? At a line. Name me 2 planes in the room that we could show this with. The ceiling and the wall, I heard. Ceiling and the wall. They intersect at that metal strip right there, and we consider that metal strip a what? A line. About 3 planes. How would 3 planes intersect? Could be a corner, so it could just be a point, right? Does it have to be? What if I did this? Is this a plane? This a plane? This a plane? So if I do this, if I can hold all 3 of these planes up here, which apparently I can't because I keep dropping them. If I hold all 3 of these planes up, where do they all 3 intersect? They all intersect at the line that's the spline of the book, right? So that's something a little different. Does it have to be that way? Could be the point. Could it be some other way? Yeah. If desktop is a plane, right? If my book was a plane, it's intersecting there at a line. Jameson's calculator could be a plane. Now they're intersecting, the 3 planes are intersecting at 2 different lines. And actually the 3 planes altogether don't intersect at all, right? So lots of different things that could happen there. Understand between this and use segment addition. We got point N here, point T. If they tell us point B is between those 2, where's point B going to be located at? Does that have to be right in the middle? So point B might be somewhere like this. We had problems earlier in the chapter, unlike the one that we just got done doing, where they told you something like, they might have told you that N to B was 5, B to T was 12, and then we had to find what? That whole length. How did we do it? This plus this has to equal the whole thing. Now we also had other ones that maybe they did something like this. they told us from here to here was x, here to here was 2x plus 4, and maybe the whole thing was 15. How'd we do those? Go ahead, Cooper.
Then you do x, like x plus 2x plus 4, and then equals 15.
So this plus this equals the whole thing. Now the problems that we just got done doing, is that the way you set those up? That one was a midpoint, right? So we said this part had to equal that part. You got to be able to tell the difference. Number 9. Sorry, my other stuff's in my blank here, but I'll just write it down below. Blank are segments with the same measure. What goes in this blank right here? What kind of segments have the same measure? Congruent. So congruent segments, that's what goes in the blank. Congruent segments. What's the word congruent mean again? Equal or same measure. If I'm drawing a picture, we got N, we got T, and we got A there. How can I show you that these two segments are congruent to each other? Draw a line like that. What do you mean? Put the little tick marks on there, right? And that tells you that they're congruent. What's the symbol for congruent? Equal sign with a little tilde above it, right? A little curvy thing above it. Make sure you know that that means congruent. Same measure, equal. Number 10, find the length of a segment on a number line. These two sort of go together. If we're on a number line, how do you find the length of the segment? It was easy. Count. On the number line, if we're on this number line, we're trying to find the distance from this point to that point, we just count. Can we do the same thing on the coordinate plane? Coordinate plane, we had to use what? It's up there on the board. The distance formula. We had to use the distance formula. Probably don't need to write down the distance formula because all of you have it memorized already. Remember with distance formula, you subtract the x's, square that answer. Can you guys ignore that extra mark going up through there? Should I erase it? Well, it's saying nothing, so yes, I'm going to erase it. Plus, what's the second half of the formula? Subtract the y's and square the y's. Remember, when you're doing this formula, you're going to plug it all into your calculator just like that. Do this part, you can plug all this into your calculator as one thing. Do that part first, then take the square root. Otherwise, your calculator a lot of times will tell you the wrong answer. How many answers you got when you're doing the distance formula? Just the length of the segment, all right? How many answers you got when you do the midpoint formula? X and Y. Please make sure. How you going to know the difference? I put a problem on there. How you going to know when you're using the distance formula or when you're using midpoint formula? What's it going to say if you're using the midpoint formula?
Find the midpoint.
Find the midpoint, or find go halfway or something like that. What if you're using distance formula? Find the distance or the length. Next one, locate a point on a number line given a fraction. So we're trying to find the one coordinate on a number line. Ignore that. Anybody have that formula there somewhere? So A over B, is that what we used? Stupid pen. That's if we're on a number line. Remember your x2 and your x1 are just your two. If we're on the number line, that's our number line. We're given this point. We're given that point. We got to know which one we're starting at and which one we're ending at. And make sure we put them in there right. Remember this, we start. This is where we stop. Given a ratio, how do you find the coordinate on a number line? Formula sort of the same as the one here on the board. N times x1 plus m times x2 over m plus n. Is this a hard formula? Looks hard. All you're doing is plug it in. They're going to tell you all this. The ratio, let's say somebody give me a ratio. 4 what?
3.
4 to 3. The 4 is the m, the 3 is the n. They're going to give you the coordinates of the, sorry, that shouldn't be there. They're going to give you the coordinates of the 2 points on the number line. That's your x1 and your x2. And then all you do is take all of these numbers and plug into that formula to find the coordinate wherever we want to end up here. Remember, if we're at 4 to 3, 4 to 3, you're getting how many parts of the segment? 4. 1, 2, 3, 4. So you're getting all this, and your friend is getting 3 of the parts. We're just splitting it up, trying to figure out where we're splitting it up at right there. That's if we were on a number line. It's got a little harder when we did what? When we went to a coordinate plane. So on a coordinate plane, we're given a fraction. What's our formula? If I have it memorized, probably not. It's right up here on the board, isn't it? x1 plus a over b times x2 minus x1, comma, y1 plus a over b times y2 minus y1. I'm trying to make sure that you guys see that those parentheses on the outer edge are the whole thing, right? Again, is this formula all that real difficult? It's not difficult. It looks difficult, but it's not that hard. They're going to tell you the 2 points, the x's and the y's, and they're going to tell you the fraction. Then you just plug in the numbers. What makes it hard is if Jacob tries to do it all as one thing instead of doing it separate. Do the x, find that answer. Do the y, find that answer. So anybody remember if we're given a ratio, how we do it? What changes in the second half of the equation or the formula? It's just the y's instead of the x's. Exact same thing, just the Y's instead of the X's. Everybody knows this is a comma, right? Comma. Do what?
It says that, I said it looks like a potato.
As long as it doesn't look that way on your paper. Again, do the X part first, come up with that answer. Do the Y part, come up with that answer. And on every problem that deals with any of these, I'll give you a little graph on your paper there. You have your starting point, your ending, or your stopping point, and know that we're going to split it up at some ratio of like 2 to 3. Then we go, we want 2 parts on this side, we want 3 parts on that side. And that's we should be somewhere about in there. Use the graph to make sure that you're getting somewhere close to the answer if you need to. Last thing, understand midpoints. What is a midpoint?
In the middle.
Splits a segment into 2 congruent segments. Midpoint formula looks like this. X sub m, comma, y sub m, ignore that, equals x sub 2 plus x sub 1 divided by 2, comma, y sub 2 plus y sub 1 divided by 2. Ethan back there is going to say, Ebersole, you wrote the x's and the y's backwards. For this formula, it doesn't matter. So I think the first time I gave it to you, I had x sub 1 plus x sub 2. This time I got x sub 2 plus x sub 1. It makes no difference because you just add. Number 14. Understand the segment bisector. Explain a segment bisector to me. What's it do? What's a segment bisector do? How many pieces? 5 means what? Splits it into 2 pieces. What do we know about those 2 pieces? They're congruent. They're equal. Give me an example of a segment bisector. A midpoint. Midpoint splits a segment into 2 equal parts. So a midpoint is a segment bisector. Does it have to be a midpoint that bisects a segment? If I draw this line down through here, could that line split that segment into 2 equal parts? Yeah. Could be anything that splits it. Now, once we have this, is there some point right there? And that point would be a what? Midpoint. What you're going to do next on your computers, go to the book website. Gotta try to get mine set up. You're going to go to the book website, so it'll take me a second to get there and stuff. That means you got a second to get yours set up. I want you to get to this page. Dylan, you guys are a lot smarter than my other classes, so this is easy, right? You're probably thinking, why is Ebersole waiting so long? Let's get going. Because you're on it. Everybody to that part. Down at the bottom, you'll notice it says assignments. Everybody see here where it says assignments?
Yes.
We want to go to the one that says dynamic module practice. Dynamic module practice. So you want to go down to it, click on it. Then once you click on it, we want to hit view. Sorry, mine reset. I gotta go back and try it. Yes. Go. Go. Yes, you got it. Thanks. If you get to there, you can go ahead and start trying it. I'm sorry, it's, like I said, I don't know what you guys see, so I can't tell. Now mine, I thought I had it figured out, now it's switching back to other stuff. It's not letting me see what you see anymore. I thought it was. You can go ahead and start trying that if you want, and I'll be on there here in just a second. Ethan, though, you didn't think I was smart enough to figure it out, did you? I did. You liar. You thought I was so dumb I couldn't figure that out. Does everybody see this? Yes. Took me longer than it should have, but when we do stuff like this, number one, I hate doing stuff like this because it makes me look stupid because I can't do it. But everybody tells me that Dominique would rather do stuff like this than listen to Ebersole up there talking. So I'm trying, believe me. And when your folks tell you that you can't teach old dogs new tricks, well, Ebersole's trying to learn some new stuff, and he's about as old as they get. Probably had some of your parents in class. We're going to do these questions. We'll do some of them together. We probably won't get through them all, so we'll do some of them together. I think they sort of switch yours around, so mine might be a little different than yours. All right? So when I look at this, my first one up there, that figure is a what? Array. I don't know. Is yours array? Some of them, I think some of them are different. Or some of your guys is different. They got different letters, I know. Let's just do mine up here. How would I name that ray? What two letters? So if I click on that box and type in P, Q, is that the correct name?
Yes.
Almost. What else do we need?
The
The symbol. Which one is it? This one?
no.
This one?
Yes.
So you click on that. Now again, yours might be different, so make sure. Somebody in first block said, I typed in all the exact same stuff you typed in and all my answers are wrong. That was because they had completely different letters and stuff, and I didn't know that. We go to the next one on mine. That is a what? That's a line segment. So click on it, go to the box. What two letters am I going to use? S and R. Which one of these symbols? Third one. Go to the next one. This one is a what? A line. UT. First symbol. If I can click on it, it won't let me. Okay. Then you can hit check answer. Woohoo! Got it correct. Then guess where you go? Next question. Again, your picture might look completely different from mine. I'm looking at this. Does yours look different? Because mine looks exactly the same. I don't know. Sort of. Mine almost looks exactly the same as Dominique's. How come mine's screwy? Is your guys is messed up? Are the letters on the points and stuff where they should? See how mine's messed up? I wonder what happened. Try it on your paper there, or on your computer. Just trying to see if there's some way I can get mine to actually look right. I think this X is supposed to be up here, and D is supposed to be with that thing, I'm guessing. What's collinear mean again? Same line. What's coplanar mean? Same plane. Which point in my picture is not on plane X? Even though my picture's messed up. Which point's not on plane X? Which one goes through? What goes through the plane? That line does, doesn't it? It goes through the plane. So which of these points is not on plane X? A right there. Segment AD and segment what line would intersect with segment A? With line AD in my picture? First of all, is line AD in my picture? Could you draw it in there if you wanted? Yeah, so it'd go like from here down to there, something like that. What line would intersect with that? Line AB. So let's put AB in there, see if we get that one right. Another name for plane X. Uh-oh. We don't call it plane X. How many letters do we got to use? 3. So pick me 3 points that are on that plane.
Yeah.
E, F, and G. Is that going to work? Why not? They got to be non-collinear. So E, F, those two will work, but we need some other point. What's another point that's on that plane? D, E, F, D. Let's check and see if we're right. I got all mine right. Did you guys get all yours right? Yours is thinking. If you didn't get it right, what can you do? Look back at it. Does it give you the answers? It doesn't give you the answers till you get them all correct? Or just try again? It tells you which ones are wrong though, right? It doesn't even tell you which ones are wrong? That sucks. The third one, lines that belong to the same plane and never intersect. Wow, we didn't even have that. We didn't even do that in this chapter. If they never intersect, what do you know about the lines? They're parallel. Not sure why they stuck that in here. Having exactly the same shape and same size. Congruent. We said same measure, right? But same shape, same size, that means congruent. Next one, set of points in a plane that lie the same distance from a single point in the plane. We talked about this one. It's not even on there. Oh, yeah it is. Yeah, no, we didn't talk about this one. I thought they were using something else. Why are they doing this? What in the world? This is
You haven't gotten to the drawing one yet.
Yeah, where'd it go?
belonging to the same line. What's something on the same line? Collinear, that one we talked about.
So what do we do with this like without
I got it.
If you miss something and it's something like, we didn't talk about parallel, we didn't talk about a circle. I don't know why they would stick those on here. Were those on your guys' also? Intersecting lines that form a right angle. Yeah, we haven't talked about that yet. It's perpendicular. We talked about that next chapter. Why would they put that in module 1?
Because they do.
Yeah, this book's not. I think it'll just let you skip to the next question and miss it, won't it? We'll let you guys do that? This one we talked about. If FG is 9 and GH is 7, how long is segment FH? 16. So we can type that in there. 16. You guys said there was one that's harder up through here?
Yeah. Question 5 here.
Question 5.
If it's the same one I have. Yeah.
Use a compass and straight edge to construct a segment congruent to RS.
It's just weird that they ask us.
Yeah. What you would do with this, and we're going to do some of this, put that point right there on there. Put that point right there on there. Now you got that width. You're going to come down here, P. You're going to put that on there, and then you're going to draw an arc like that. Hey, this is pretty cool. You're going to draw an arc like that. And then what we want is if we go back up here and we do this, we grab our pencil and we go from point P right to that. Get rid of the pencil. I don't know if they want us to actually erase stuff. Erase that. Now I'm just going to take this pencil. I'm going to draw.
Yeah, put the straight edge down first.
Oh, you got to put the straight edge down. So see, I'm learning stuff. You can move it around.
Yeah, you do it from the eye.
Wow. That's hard to do.
You have to grab the pencil again.
How come it won't let me move it anymore?
It's already put on.
I want to do it again. I didn't do it very well. Okay. There's 2 assignments that are on there. Try those 2 assignments. No test next time. Test will be Friday. So try to finish this. Again, I'm doing this because I want to see, I want to figure out, you guys, that way you guys can tell me how these things are working. I'll take care of the desk. Don't worry about them.
You say those two, do those two.
The 2 assignments, both of them that are on the computer.
Mr. Ebersole, I want to be here. Actually, I'll get to you later.